Okay, review of the workbook is, I guess, actually second because we have already watched our morning math review. Okay, here we go. So first of all, we have to look at the table of the individual results. So that is this one, right? And then the second question is related to the combined results. Okay, so first of all, look at the table. Okay, what's the experimental probability of landing on each of them? Well, we know in total there are 10, there were 10 times that the spinner had been spun, right? Even though there's also 1, 2, 3, 4, there's also 10 positions, we have to be aware that the fact that we are putting the number of times the experiment was conducted on the bottom, so it should be out of 10. Now, how many times did B occur? B occurred only once. How many times did C occur? C occurred twice. We can say that, or we can say 1/5. How many times did D occur? 1/10. B or C. So that means we are successful if we have either one of these ones. So that should be 3/10. And then A or D would be 7/10. All right, next we have to look at the combined results. What is the experimental probability of landing on each of them? So they told us that there is 100 in total. Also, if you were to add them up, you would also be able to quickly equal to 100. So we know the bottom number, the denominator, is 100, because that's how many times it was conducted. How many times it'll land on B? This is so easy, 19. C should be 8. D should be 22, and then B or D would be 19 plus 22 is, what is that, 41. Okay, there you go. So hopefully you guys did very well on that. The whole page is out of 9. Okay, all right, next, moving right along. Okay, so Tatiana spins the pointer on the spinner several times. Okay, here are her results. How many times did she spin the pointer? Oh, that was nice of them to even ask that question for us, because that is what we had to figure out to know what the denominator should be in experimental probability. Oh, wait, I don't know why I wrote 10, because maybe it's not 10. Okay, so here let's count them up. We know that is 12, this is 20, and then 8. So that is 40, right? Okay, how many times? Okay, so 40. So we know something's going to be out of 40. That's how many times the experiment was conducted. What fraction of spins were A? 12, right? If you wanted to reduce that, of course you could, which would be 6/20. Can we reduce it again? Yes, we can, which would be 3/10. So lowest form would be 3/10. Okay, next one for B, we had 20/40. So lowest form of that one, hopefully you can do that in your head, would bring you right down to 1/2. So any of these equivalent fractions would work out. And then C would be 8/40. So can we reduce that? Yes, we can. It would be 1/5, right? If you were to do that, magic number is 8, 1/5. Okay. Next, okay, a coin is tossed 100 times. Heads is showing 43, and then tails is showing 57. What are the possible outcomes? Okay, possible outcomes are heads or tails. What is the experimental probability of the tosses? Okay, so how many times was it tossed? 100. How many times did it land on heads? Heads, 43. Okay. Next, how many times did it land on tails? We know 57. Okay, now what is the theoretical probability? This is going back to our class, what was that? I guess that was on Wednesday, of the tosses shown. Okay, so of heads, we know that it's likely to be half, right? 1/2 would be the theoretical probability, or in this example, we would expect 50/100 times, because they spun it 100 times, right? And then the same thing tails. We would expect it to be exactly half, 50/100. There you go. Okay, cool. A funny story for this. My dad told me, I remember when I was learning this myself, he told me that he had to do this experiment in university. I think they had to do it for some statistics class. And he and his friend were flipping these coins, and then once it actually landed on its side. So like, I think they were using maybe a loonie or something, and it didn't land straight up. It landed on its side, which is crazy. So like, what are the chances of that happening? Probably like 1 in a million. Anyway, kind of funny. You guys could try that. Probably spend a long time doing that. Or kind of like your bottle flipping thing, right? What would be the probability of that happening? Okay, so next one. You did have to do this one. And I'm not going to be able to fill out this portion for you. So hopefully you just were able to do that on your own. I'll fill it up like in a fictitious way, just to sort of show the point of what we would do in the answers below. So what is the theoretical probability? Okay, so TP is the number of preferred, right, over number of total possible outcomes. Okay, so here we go. Okay, let's figure out what the denominator should be first for each of them. So we have 10 points on the spinner, so we know our denominator is 10. And then what is the theoretical probability of landing on an A? So we have 1, 2, 3, 4. 4. And then landing on a B, we would have 6. Okay, is that right? 1, 2, 3, 4. Yeah, of course, 6. Okay, there you go. All right, now, if you actually spun this, I'm super curious what you guys got. Actually, you know what? Let's post this. I'm going to make this for you guys to post on our Edmodo page. I'm super curious what you actually got. This will be cool for us to see as a class. All right, so let's see here. Okay, so say for example, well actually no, I'm not even going to show this, but basically what you'd have to do below is you'd have to say the theoretical or the experimental probability is whatever you got up here, it's just going to go on the numerator, and then whatever you got here is just going to go as the numerator. Okay, so I'm going to ask for this in our on our Edmodo page, and I'm super curious to see what you guys get. Okay, well done, and post this immediately so that we can maybe even do this